Hello everyone, this is stage 6. I'm Christina, your host for today, and we're starting with our last session for today, but one of the most interesting, artificial intelligence programming with TSQL. Our speaker is Sam Nasr. He's been software engineer for 30 years or more, with the focus on Microsoft technologies. He's a 5-time MVP, a leader of study groups and Azure Cleveland user group, and author for Visual Studio magazine. Sam, at the dawn of AI, what can we do with TSQL?
You can do a lot with TSQL. Thank you, Christina. I appreciate the introduction. Let me go ahead and discuss the more detailed answer to your question of what you can do with TSQL. And so with that, first of all, good afternoon, good morning, or good evening, depending on which part of the world you're joining us from. Once again, my name is Sam Nasr, and this is the Artificial Intelligence with T-SQL. And a little bit about myself. First, my Twitter handle is @SamNasr, so you can reach out to me there. I've been a software developer since 1995, so going on 28 years now. I'm a senior software engineer for NIS Technologies, where I've been certified with a few certifications from Microsoft. And as Christina mentioned, I'm also running the .NET study group, as well as the C# VB.NET user group in the Cleveland area. I've authored multiple articles for Visual Studio magazine, and I've been a 5-time Microsoft MVP and just recently received my 6th MVP award. A little bit of a shameless plug for the C# user group. So it's hosted in Cleveland, however, and we meet every month, and the meetings are free of charge and open to the public. Even though it's hosted in Cleveland, we actually open it online, so you can join us from anywhere. And you can find meeting information posted on meetup.com, and we cover a variety of topics related to .NET. So typically, if we were in person, I would ask, how many people in the audience are developers, and how many are hobbyists, how many are data scientists or engineers, and how many are DBAs. So this talk is going to be geared more towards the developers and less looking at DBAs. So we're going to be targeting the first 2 bullet points, just as an FYI. And so for starters, you might be asking, why use artificial intelligence with T-SQL? Well, there's many advantages to it. First, you can use the existing data that's in the database that you have within SQL Server. So there is no importing of the data that's needed. Second is that it has integrated functionality with Python and R libraries, all within SQL Server. And because it's in SQL Server, naturally, you have accessibility to doing all these tasks using T-SQL commands. And by saying these tasks, I'm referring to being able to fully manage the model. So you can train it, you can test it, you can store the model in the database, and then you can use that stored model that you have in your database and be able to make a prediction. So looking at the architecture to see how it is that we can actually implement this, if you see within the slide, starting from the very top, some of the advantages that are included within this architecture is that we have familiar tools for developers. So naturally, if you've used SQL Server before, you probably used SQL Server Management Studio, and you've used T-SQL to do your queries and your updates. So you already have a familiar set of tools that you've worked with in the past. Starting in 2016 and later, Microsoft started to implement R and Python integration within SQL Server. And it's been slowly progressing, and the features are increasing. So that's another advantage, is that you have everything integrated within the database. And because of SQL Server's rich environment, it gives you the ability to scale and optimize the data, all using the same database. In addition, because of its many robust features, you also have the ability to do analytics that is close to the data. So you no longer have to import it or reach out to another server, but rather everything is combined into one environment. And just like we've seen with many versions of SQL Server going way back, you always have the ability to secure it. So you can provide access for the tables on a more granular level and be able to identify who can query it, who can see the data model, etc. So many features available within that extensible architecture for SQL Server. Now, how do we actually implement artificial intelligence with T-SQL? So as I mentioned, starting in 2016 and later, Microsoft started to integrate features for Python and R libraries. And so those have been utilized for ML services or machine learning services. And we can utilize these Python ML libraries to be able to create an artificial intelligence or create a machine learning model where we can use it to make predictions. And naturally, these operations are going to be done in T-SQL, and we're going to utilize them by storing them in stored procedures. And so this gives us the ability to make it optimized because it's already it gives us the ability to make it optimized because it's already in a stored procedure. In addition, it's also reusable, and it also gives us the ability to call other procedures or to be called by other procedures or other applications. So we already talked about the advantages, talked about the extensible architecture. Now, what is it that we need to do to actually set things up and start working in it? So first and foremost, there's a pre-installation checklist, which we'll talk about in just a second. Then after that, you need to install ML services. And then that's going to also include some runtime packages for either R or Python, depending on your language of choice. And then we do some configuration and debugging, and then we're off and running where we can actually start implementing the model using T-SQL. So targeting that first bullet point, the pre-installation checklist. I'm not going to go into a great level of detail, but there's a variety of things that you need to check, and this is from the Microsoft Docs website. But essentially, obviously, you need a database engine instance already installed. As far as always-on availability, it's supported for machine learning services. And there's a variety of other things, as you see there, that need to be implemented. Now, with the installation procedure, a lot of times you've seen that it can get a little confusing because at the very top in that red box, you see that you have machine learning services. But then on the bottom where you see the big X, you have the shared features also stating machine learning services. So the difference is the top one is the one that we want, because the one listed with the X on it, that is a standalone server. So if you were to utilize the option, the second option listed there with that big X through it, essentially what that's doing is it's setting up that server only as a machine learning server. And hence you see the standalone in parentheses. So we want to be able to integrate with our database. We don't want to create a new server that's just for machine learning only. You would do that only if you're running a DevOps operation where you want dedicated servers to do the training. In our case, we want to be able to integrate the data with the machine learning services. So then the next step is to be able to set up the runtime libraries. And this is a chart from Microsoft Docs where it shows you which version of Visual Studio, which version of SQL Server you have installed, and then the appropriate runtime libraries that are applicable for either Python or R. In our case, we're using SQL Server 2022, and we're using the 3.10.2. And then in addition, if you look towards the bottom of that slide, you see that we have a couple packages that are available. We can use the RevoScale for Py or Python, or we could use the Microsoft ML packages. And again, that comes with the constraints with the Microsoft ML, applies only to SQL Server 2016, 17, and 19. Now, once we got all that installed, we need to do some configuration. That configuration essentially entails running the sp-configure stored procedure. And what that is basically a variety of different settings, 25 to be exact, as you see here, and they're accessible through the stored procedure sp_configure. And more specifically, what we want to do is to be able to enable external scripts. And so you see in the command towards the top, execute sp_configure, and then we're specifying in quotes external scripts enabled, and we're setting that value to 1. And then you see on the bottom portion in the output, we see that we have external scripts enabled with the config value set to 1. So once we do that, now it gives us the ability to be able to call external scripts, as the name suggests. And those scripts could be either Python or R, and that's how we facilitate machine learning. More specifically, looking at the overall architecture. So first of all, this architecture, if you notice at the top, I have the Windows symbol because this is the architecture for running it on Windows. This is what's actually under the hood and what is actually implemented. For Linux, it's a little bit different, but I won't be covering that here. But essentially within Windows, what you have is the SQL Server process. And as if you follow the numeric bubbles, once you have the SQL Server installed and you make a call out to running an external script, it makes a call to the Launchpad process. And this Launchpad process consists of the Launchpad executable, and it also calls the launcher DLL. Once that is called, then it passes the execution over into the next step, where we have an extension process that integrates with BXL server as well as the SQL Satellite DLL. So this Launchpad is used to invoke external runtimes going from step 2 to 3. And this allows us to be able to call library-specific logic for loading the interpreters and the libraries. Now, once it gets to step 4, where we have the BXL server, that's another executable that manages communication between SQL Server and the language runtime. So our overall goal is to be able to integrate with R or Python. So we need to make a call within our store procedure in T-SQL, be able to call out and execute a Python script. And so this is the overall flow that we have to manage. Once we get to the BXL server, so this manages the communications, and then it also communicates with the SQL Satellite DLL. And what this does is SQL Satellite is essentially an extensibility API, and it supports external code or external runtimes. So going from the very start, from 1 all the way to 6, this is a continuous process where we're making calls going out to the Python libraries. And so each of these libraries, they communicate with each other in order to make that happen. And so moving on, now that we have an overall picture of the architecture, we want to look at how it is that we're going to develop a model. So a model is essentially a process that, or creating a process that allows us to be able to make a prediction given a specific set of data. So first and foremost, we have to collect and load the data. And then we create a pipeline for using that data. And then we call the fit method, which essentially trains the model on that data. And then we evaluate the data to see, is it accurate? And if it's not, then we cycle through the process again, where we collect the data, create the pipeline, train it, and then reevaluate it. Once we're satisfied and the evaluation process is successful, then you see on the lower portion of the slide is that we actually, where we save the model, and we do that using the save method. So once the model is created and it's able to make the right prediction for evaluating, then what we do is we want to be able to utilize it. And so we're going to load the model and then be able to make a prediction using the model that we created. Now, this is a general overview of how a model is created and how we get to the process from data over into actually being able to make a prediction using a model. So you probably heard enough and you actually want to see a demo, and that's always the best way to explain things, is by utilizing a demo. So what I'm going to do is open up my SQL Server Management Studio, and then what I'm going to do is essentially walk through the steps of how we got here. So if you recall, first and foremost, what it is that we had to do, we had to configure it, right? So just simply calling the sp configure allows us to be able to see the values that we have set for our 25 different configuration settings. Here we have external scripts is already enabled. But if it wasn't, I would just simply call this T-SQL where I would enable the script, and then I would want to reconfigure it. And let me close this down. Okay. So once I have that done, now I need to install machine learning services, which I already done. Now I am ready to actually start executing some T-SQL to be able to train the model and be able to use it. So these scripts are intended so that they can be executed multiple times over and over. And so what I have here is basically a short and sweet demo that's all about home prices. So home prices in the United States are based on a variety of different factors. As you see here, it's based on the square footage as listed here. It's based on the number of bedrooms, whether there's a basement, is the basement finished, does it have a swimming pool, the size of the backyard, does it have a deck? And then other things that could work against the price are things like, is the house fire damaged? Was there a portion of the house where there has a fire occurred? Is there mold? Is there insect damage? So there's a lot of different factors. But as you see, I pretty much commented all these out because I want to make things very simple for our very first demo. And so we're just going to look at square footage, and we're going to correlate that to the price and be able to build a small model out of that. And so what I did is I have a script for creating the table for prices, and then I'm going to insert these prices into it. So first, let me maneuver to the correct database. And then I'm going to drop the table and then recreate it again. And now I'm going to insert the sample prices. And so what I have is some sample values, and they're going to be based on the square footage. So an 1,100 square foot home is going to cost $98,000. A 1,900 square foot home is going to cost $210,000, so on and so forth. So I'm going to use this as just my 4 points for my sample data, and that's inserted. Let's make sure that everything went okay, and there's my data. Now, as we talked about earlier, our model is going to be in a stored procedure, and this is where I start to create it. So I'm going to drop the stored procedure and recreate it again. Before I recreate it, I want to walk through it in more detail. So obviously, as with any stored procedure, every statement starts with create procedure and then begin. And what I'm doing here is I'm executing an external script. And I'm specifying that this script is a Python script. And more specifically, I'm going to be using the sklearn linear model library, and I'm going to be using linear regression. And then in addition, I'm also going to be importing Pickle, which is also another library used for doing linear regression and machine learning. Then I'm going to set up a data frame, and this data frame will essentially be a temporary table in memory that will hold the data that I want to train it on. The target column that I'm targeting is the price. So basically, I want to be able to give it a square footage and then be able to get a price out of it. So I'm training it that it's going to look at the price columns as the final output that I want to arrive at. I'm stating that it is linear regression that I'll be utilizing from that library that I specified up on top. And then, if you recall, we're using the fit method, as you see here, to train it on the data. So I'm passing in the columns for the data, and then I'm specifying which one is going to be my target column. So in this case, I only have square footage that's the only factor that the price will be based on. In reality, I could have multiple columns, and we'll see that in another demo. But this is just to keep things simple for our first demo. And then after I train it here, what I'm going to do is be able to take that model and dump it out into a variable called the trained model. And then this trained model will be my output parameter that I'm going to get from the store procedure. Okay, so that is the store procedure in a nutshell. Let me just pause here for 1 second and see if there's any questions in chat. And currently there is none. So I invite you all to jump into chat and let me know if you have any questions. All right, if not, let's continue on. So there's my store procedure. I'm going to highlight that portion and I'm going to create it. And we see it was created successfully. Now, it's just a store procedure. It hasn't been fed any data. It hasn't done anything. It's just sitting in SQL Server and it's ready to be executed. So I have a table here called sale price pie models. That's where all my models are going to be stored. And what I'm going to do is I'm going to drop that table because I want to get rid of any old data that I have in there from previous demos. I'm going to recreate it again. And now what I'm going to do is I'm going to call the store procedure that I created earlier. And I'm going to get a model variable out of it. So this model variable is declared up here. And all it is a var binary max. And I know DBAs tend to hate var binary max, but this is like one evil that we have to work with because we don't know how big the model is going to be. So we have to give it ample space in our database. So we set it to a var binary max. That's going to be our output variable. We're going to execute the store procedure. And then whatever model we get out of it as the output, we're going to insert it into the sale price pie models. And so we'll go ahead and execute that statement. And that's going to take a minute. And then once we're done, we'll see the results in the results window. And then we can actually query the model from the sale price pie models. And while we're doing that, let me take a quick drink. So obviously the first time I'm running a store procedure, it takes a little bit of time because of the compilation, but then once it has executed, there I see the results. And let me just fast forward down to the bottom, and we see that we have one row affected, and that is pertaining to this insert statement. So now I can see what is it that has been inserted. So I query my sale price pie models. So I listed the model name as linear model here, and then this is my actual model. So this is the formula that will make a prediction once I give it a specific value. Then I can see the output results coming from that. And as I mentioned earlier, it is a var binary max, so it is one long string essentially. And as you see, really can't make heads or tails out of it. It's not useful to the human eye, but we can leverage it within another store procedure by making a prediction. So here we have the another store procedure for predicting the price. And what this is, again, it's going to follow the same template that we've seen earlier, where obviously we have our create procedure. We're stating that we're going to be executing an external script. And then the portion that you see in red is all Python code. And what we're doing here is essentially loading up the model. Again, we have our data frame for specifying the targets. Pardon me. And then we have the output based on the specific square footage that was entered in. Actually, I think this was another example. Okay, let me fast forward to making the actual prediction. So this store procedure is already created. Now we can actually start to make a prediction on it. And what we're doing here is we have a pie sale price prediction table. And we created it using we're adding in another field now called sale price predicted. And that's going to utilize the square footage and the price and fill in a sale price predicted. So it's similar to the previous table that we saw, which is up here. So it's similar structure, similar data. So here we have 4 records, square foot and price, except down here, we're making a store procedure. There we go. We're making a store procedure that's going to populate the table that has one additional field called sale price predicted. And so what we're doing is we're going to execute that store procedure for sale price prediction. And then the result is going to be stored in that table. And now when we actually make a call to this table for the pie sale price predictions, there we see the prices that we provided, square foot and price. And then on the left are the sale price predictions. So this was following a linear regression model. The price that I stated here, 98,000, was not exactly linear. And so that's why the sales price predicted is 97,999. So what it did is it used these 2 columns to be able to identify what the price should be for a specific square footage using these 4 data points. And then it added in the value for the sale price predicted. So there we see that we were able to utilize our model that we created in a store procedure, and then we were able to populate the sale price predicted field. And see, we have a question. Is there a way to work with a Python script away of SQL Server Management Studio and just use the latter results of this work in a SQL store procedure? So, meaning you don't want to have the script in there. So what you could do is actually have it in a library, package up that Python code in a library, and then be able to use it in here. And I believe you have the ability to call it remotely as well. So either method would work. You don't necessarily have to do it in Management Studio. Please let me know if that answers your question, Mikhail. Okay, and while we're waiting for the response, any other questions? Again, I invite you all to jump in. And if there's none, then we'll continue on to the next demo. So before we move on, I just want to point out that what I did here is just simply specify 2 columns and make things simple, right? We're looking at square footage, and then we're getting the price out of it, and that's it. Traditionally, in any machine learning model, you're going to have multiple factors. And so the next example is going to be based on ski rentals. And this is for a small business where they have ski rentals. And obviously, that's going to vary on a variety of things. The inches of snowfall, the month of the year, the temperature, whether it's a holiday or not. And of course, things differ from year to year. So obviously, during the times of COVID, there was a lot of people out doing skiing, as opposed to non-COVID times where they could do a variety of other things like go to restaurants and and be able to socialize. And so the year is also a factor. And so keeping that in mind, what we're going to do is going to look at this in more detail. And for this, I had to restore a database. And before we get to that portion, the first thing that I had to do was be able to configure the external scripts and enable that. Then what I did here is I had to restore a database. And by the way, I will make all these available through GitHub. So I restored the database to utilize it, and that database is the ski rentals database. And so let's jump to that, and we'll go over into our databases. Pardon me. And we have 3 tables, and we'll talk about those in more detail. So the first one is the rental data. So this is, forgive me, don't know where this came from, but I'm trying to get rid of it. So we have rental data based on a variety of different years. So here I just did a very basic select from our rental data table, and I see that I have data going from 2013 to 2014 and 2015, and it shows me the month and the day. The rental count specifies what this is, what weekday this was, whether it was a holiday, whether there was a snowfall, and so on. And so using that data, I need to be able to make predictions on it. So that way I know if I run through the model to identify data for 2012, 2013, and 14, I want to be able to use it to predict data for 2015 and see how well that model worked. So with that, basically what we're doing here is creating another store procedure. And for the sake of time, instead of sitting and watching it chug and producing that store procedure, I'm just going to walk you through it step by step. But this store procedure has already been created. And so with a standard execute statement, we're specifying that it's going to be an external script. It's Python. We're using the same linear regression that we've used before. We're setting up our data frame, which is going to be a temporary table or a 2-dimensional array of what our data is going to look like. And then our target is going to be the rental count. How many times did we have rentals for that specific day, given those specific conditions? We're specifying its linear regression. And now we're going to be training it on all the columns. And more specifically, we're going to be looking at the target column for the rental count. So this was specified in a couple steps previous right here. After we train it, we're going to dump the model and then take this trained model variable and produce that as our output. Our input data is going to be this select statement. We're looking at the rental count, the year, month, day, weekday, snow, and holiday, and we're looking at it for everything previous to 2015. So in our case, it's going to be 2013 and 2014. And then we're going to use it to predict against the year 2015 to see what our expected rental count will be. And so we have a ski rentals, within our ski rentals database, we have this rental pie models. I'm going to drop this table and recreate it. And all it is basically, it's a model name where we're going to be calling it the default model. And then the model itself is going to be stored in a var binary field. So we'll go ahead and create that. Now we have that created. We have our store procedure for generating the pie model that is defined up above here. And now we're going to execute it and then take that output and put it into the table rental pie models. And we're going to call it a linear model. So let's go ahead and execute that. So now what it's doing, it's executing that store procedure. It's going through that table that has all my ski rental data, and it's learning, essentially looking at everything that I specified in the criteria, which are all the columns prior to the year 2015, which means it's excluding 2015, and then it's going to create a model from it. So I will select from the rental pie models, and again, I see a model called linear model, and there's my var binary, excuse me, var binary max field. And to give you an idea of the length of that field, it is 608 characters. Now I'm going to do a rental count prediction. And in a similar manner as we had done in the previous example, we're going to be creating a new table, and it's going to store that data in it. And so, again, we're using the same template where we're going to be using a store procedure to make that prediction. And it's going to go row by row, and then it's going to populate it for the year 2015. And so we have a almost identical store procedure to what we did before, where it's specifying Python. We're using the prediction, and then we're using the fields that were specified previously in our output data set, for our data frame. Except the only difference here is that the data that we're selecting on is going to be using the year 2015. So we're now going to look at 2015 and be able to assign a prediction to each column that wasn't there before. And so the result set is going to be all the input data that we have. In addition, we're going to have a rental count predicted field that's going to be added on. And so our table structure from rental predictions is going to be very similar to our rental data, except when we're now adding in this rental count predicted field. And before I execute that, let me pause for a second, address another question. What is the benefit of AI programming in SQL Server over the typical usage of popular Python libraries, such as TensorFlow, for example? So TensorFlow is obviously one type of framework that you can utilize for machine learning. Python gives you the ability to utilize a variety of other Python libraries. In our situation, we're simply using the sklearn metrics here. And so you can use a variety or any different type of library available to do your machine learning. So far for this example and the one before, we've used linear regression. However, in another example, we're going to be using a different type of machine learning library. And so in a nutshell, Python gives you the ability to use a variety of different libraries. You can also use the TensorFlow, for example, through Python as well. But the advantage of doing it in SQL Server is keeping everything integrated in one area. So this Python script, it's actually a store procedure, right? And as I mentioned earlier, because it's a store procedure, it is now stored in my database. It is now optimized, and it can be called from a variety of other applications or other store procedures. Okay. Let me know if that helps, Mikhail. And so picking up where we left off, what we're going to be doing is running the store procedure for the predict rental count. And what this is going to do is just simply populate a rental count predicted field based on everything prior to 2015. And let's drop this table and let's recreate it. And now we're going to execute that using our linear model. Fast forward down, and we see that we have 151 rows affected. So we populated it for all 151 rows. Now, when we look at that table for the rental predictions, we see that in what we're assumed for 2015, we're going to have a, based on the data that I fed it, I see that it's almost a one, actually so far it is almost a one-to-one correlation between the rental count predicted and the actual rental count going all the way down. But then you see a little bit further down, we see that we have a slight offset. So here the rental count predicted is 599, but the actual rent count from the data is 600. Okay, so the model and the data that I gave it actually came out pretty good, pretty accurate for what I have here. And if you recall, as we've all learned in Computer Science 101, or our first class in computer science, garbage in, garbage out. So, but if I have good data, I have good results. And so that's what we have here as an example. Okay. And Mikhail, I'm still waiting for your response. Let me know if that was a satisfactory answer. All right. So both of these were linear prediction models that we went through. Let's cover another one that's going to be a little bit more complicated. And flipping through. Actually, before we do that, just wanted to discuss that with machine learning scenarios and artificial intelligence, there's a variety of different scenarios that you can utilize. So we can use it for classification. The two demos that I had done were basically for regression, but you can also use it for anomaly detection, where you can predict or identify if the credit card usage, for example, over the course of 2 years. And then let's assume that a user spends $1,000 every month, but during Christmas time, they spend $1,500, for example. So you have an idea of what it is that the usage is over the course of time. But then if you have an outlier, like all of a sudden in January, they're spending $2,400, that's an anomaly detection, right? So we can use that for detecting things that aren't a fit within that. In addition, I can also use some machine learning to be able to make recommendations. So Amazon is a huge website over in the US. I don't know how it is in Europe, but every time I go to purchase something on Amazon, it always makes a recommendation of what else goes along with it. If I'm buying a cell phone case, then it will tell me, well, how about a cell phone charger as well to go along with it? Or how about a cell phone screen cover? So it's making recommendations based on previous purchases that other customers had bought, and it's making that recommendation for me. In addition, I can also use it for a time series or looking at sequential data. And this would be for forecasting product sales and being able to identify what our product sales will be in the future as well. And then image classification, that could be used for identifying whether an image fits a specific template, if you will, for example, using medical imagery. If we look at, let's say, a heart, for example, if there's a swollen heart muscle, then we can see that, let's say that it has more of a black portion to it. Then we can use that for image classification, where we can feed it multiple images of a heart, with some of them showing that it has a swollen heart muscle. And then that will also be classified in a different category as well. So we can feed it a variety of images, and then it can take those images and classify them in different categories. What I want to do for our next model is going to be the iris demo. So the iris is a flower, and as you can see on the bottom, there are 3 different varieties of irises, all based on the number of petals and the size of the petals. And there's also something called the sepal, which is the portion pointed out to on the lower part of the petal here. So it varies on the length and width of the petal, as well as the sepal. And so with that, let's dive into a specific demo. All right, and Mikhail is happy with the answer, so good to hear. And I, again, invite you all to jump in with any questions you may have. So going to our third demo. So this is going to be predicting what type of iris flower we have based on the metrics that I mentioned earlier, the length and the width of the petal and the sepal. And that will help us to identify what the species is. And so, so obviously, pardon me, we have a table that's going to highlight those items for the sepal length and the petal length, as well as the width, and then be able to identify what the species is, and then give it an ID. So we have a table and that contains that data. We also have another table called iris models. And so let me go ahead and query those tables just so you get an idea of what it looks like. Select star from iris data. Wrong database. So we change to our iris SQL. Now we're going to look at the data. And there we have an ID that is pertained to the each record. So this simply serves as the primary key. We have the sepal length and the sepal width, petal length and width, and then what type of species it falls under, and then the specific species ID that correlates with that. And as you see, we have 3 different varieties, 150 records total. So now I can go over into my data, and I have an iris models table. Let me drop that table, and then we'll recreate it again. And similar to what we've done before is that we're going to have 2 columns essentially. It's going to be the model name and then the actual model itself, which is a var binary max field. So for our model, we're just going to call it the default model. And let's create that table. There's already an object named iris models in that table. Because I forgot to drop it. So let's drop it, recreate it, and done. Okay. Now, in the past demos, we've used the linear regression. Here, we're using the Gaussian naive Bayes, or GNB for short. And as stated here in the comment, it is a technique for machine learning that's used to identify things based on a variety of different parameters and doing classification. So once again, we're going to be doing it in our stored procedure. We're going to utilize a Python script, except this time we're using a different library. And then we're identifying our data, where we're specifying the data frame, and then we're looking at the species, and the species ID is going to be our target, okay? Because that's what we want to be able to teach it to be able to predict. And then the result set that we get back, that's going to be outputted. And all right, so this stored procedure is already created. And for the sake of time, I will step through it a little quicker. So now we need to execute the stored procedure. And so what this is doing, it's going to go through all the records, identify the specific species based on the parameters of both length and width for the petal, as well as for the sepal. And so we'll give it just a second to chug through it. And as we see, it completed successfully, where we have 150 rows. Now when we query the data, basically it updated the species ID, and it was able to run through all 150 records and update it with the species ID. So the whole point of this, and I apologize, I have to rush through it because I need to wrap it up. But essentially, we're using multiple variables or parameters, and also a different classification as opposed to linear regression to be able to categorize these flowers based on their dimensions. And then a couple other things that I wanted to mention before we wrap it up. So for improving performance, always have more data, but not just more data, clean data. Again, garbage in, garbage out, but if you have clean data, you're going to have a better model that's being produced. You want to have data with context. So as with our home pricing, we didn't want to just provide just the square footage alone, but we want to look at a variety of different things, whether it has a basement, has a swimming pool, the size of the yard, etc. In addition, I can utilize different algorithms to be able to create a better performance. So and by better performance, I don't mean speed, I mean be able to have a better prediction model out of it. So I used one specific library, the scikit for Python, but there's also a variety of other libraries that I can utilize as well. So advantages. It integrates functionality with Python and R libraries. We have accessibility using T-SQL commands, and we use existing data within the database, so I don't have to import it. And I can utilize T-SQL commands to be able to train, test, store, and be able to predict the model. And I've done all that using store procedures and T-SQL within Management Studio. Some additional references that would be available. I have a set of links, and I'll make this available on my GitHub for a variety of different articles related to what we talked about. And then how to reach me. Essentially, the shortcut is linktree/Sam Nasr, and you can find all my links available through there. But to be more specific, my email if you have any questions. I know we had to kind of rush towards the end, but feel free to reach out to me directly with any questions. snasr@nistechnologies.com. My Twitter handle @SamNasr. And if we're not connected on LinkedIn, I invite you to do so. So feel free to reach out to me on LinkedIn. And with that, I thank you all for attending. It's been a pleasure to present the days, and let's keep the conversation going. Feel free to reach out to me with any questions. I'd be happy to answer any questions you may have. And with that, thank you for having me.
Thank you so much, Sam. That was a very useful presentation, straightforward. I think we all see what are the benefits of using TSQL. There are many teams that have a lot of data, they don't know what to do with it in SQL. So maybe having the tools in front sometimes is very inspiring. Thank you very much. Thank you for answering the questions. And thank you, everyone. With this, we wrap up the day at Hall 3, Stage 6. Now, I invite you, everyone, to move to Hall 5, where we're ending with a keynote. And let's wait for tomorrow, when we start also with a keynote, then with a panel discussion about software architecture. So it's going to be a very exciting day as well. I'm Christina. Have a great day.
Thank you. Bye, everyone.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship ever start.